Hello everyone and welcome back to another episode. Today we're going to be doing some more kinematics problems, but with this one we're going to be having components in the x and in the y direction, and we're going to figure out how to find the angle of which an object is going to hit the ground when it goes off a surface at a certain height. So let's read the problem. A physics book slides off a horizontal tabletop with a speed of 1.1 meters per second. It strikes the floor in 0.48 seconds. Ignore air resistance. Find the height of the tabletop above the floor, the horizontal distance from the edge of the table to the point where the book strikes the floor, the horizontal and vertical components of the book's velocity, and the magnitude and direction of its velocity. All right, so let's get right into it. First, I'm going to draw a picture. So here's the top of the tabletop. Here we have our physics book, which we know is going 1.1 meters per second, all in the x direction. And we know that this tabletop has a certain height. Let's call that y naught. Here I'm just going to draw the legs of the table to make it look somewhat like a table. And then we know that this book is going to do, this book is going to have a path that looks something like this. It's going to go off the tabletop. It's going to hit the ground there, and it's going to travel some distance. We're going to call that distance x, and we know that it takes 0.480 seconds to get there. And when it strikes the bottom here, it's going to have an impact velocity that we're just going to call v, and we'll be able to deal with that later. But first, let's just write what we know. So setting up our kinematics equations is going to look like this. I'm going to do the x side first. So we've got initial x. We can call that 0. We're just going to call this point at the tabletop, we're going to call that 0. We're going to say x, we don't know. We're going to be trying to find x. The initial velocity in the x direction is 1.1 meters per second. It turns out that the final velocity in the x direction is also going to be 1.1 meters per second, and that's exactly because we're ignoring air resistance, so that means the acceleration in the x direction is 0 meters per second, right? Because if we have no acceleration, then that means that the initial velocity in the x direction has to equal the final velocity in the x direction. So that checks out, and then we know that the time it takes to reach the floor is 0.48 seconds. Okay, then let's do the y. We know that we don't know the initial y, right? Because that's the height of the table. That's what we're trying to find in part A. We don't know the height of the table. We do know that the final displacement in the y direction is 0, right? Here at the ground, that final position is 0. So we know that that's 0 meters. And then we know that the initial velocity in the y direction is 0 meters per second, right? Because this book is only sliding in the x direction. There's nothing happening up or down. Okay? And then we don't know the final velocity that it's going to strike the ground. We do know the acceleration due to gravity is negative 9.81 meters per second squared. And we do know the time is equal to 0.48 seconds. Okay, so I'm going to start with the y components over here on the right. And you can start with either one, but I'm just going to start with the y's because that's going to give me part A first, the height at which the book is going to fall off the table. All right, so we're going to do the long equation. So it's y minus y naught is equal to vy naught t plus 1/2 ay t squared. Okay, now let's plug in what we know. We know that the final position is 0. We don't know the initial position. We know that the initial velocity is 0 in the y direction, and we know acceleration due to gravity is negative 9.81, and we know that time is equal to 0.48. I'll put the squared up there because there's this little squared right there. Sometimes I like to put that squared right there so I remind myself to square it. Okay, so we've got something that looks like this. We've got negative y naught is equal to negative 4.905 times 0.48 squared. The negatives cancel. And we've got a y naught value of 1.13 meters. Boom. That answers part A. I said I was going to do this in blue, so I'll change it to blue. There we go. So boom, part A, done. That is the height at which the book has dropped from. All right. Now let's do the short equation where we've got Vy minus Vy naught is equal to Ay times time, which is equal to negative 9.81 times 0.48, right? All I did here is I plugged in negative 9.81 for acceleration due to gravity, and I plugged in 0.48 for time. And I know that the initial velocity in the y direction is 0, so that leaves me with Vy is equal to negative 9.81 times 0.48, which gives me a velocity component in the y direction of 4.71 meters per second. That's going to help us later with part C. So let's underline that, because that's going to help us out later, all right? So we've got that done. That's the short and the long equation for y. Now let's move on to the x. I'm going to do the x in black. So we'll start with the long equation. We've got x minus x naught is equal to vx naught times time plus 1/2 axt squared. All right, now let's plug in what we know from this stuff above. Let's plug in what we know. We know the initial x, we called that 0. We don't know the final distance. We're going to be solving for that. We know the initial velocity is 1.1, and we know that the time is 0.48, and we know that acceleration is 0, so that's going to zero out that whole term, right? We said ignore air resistance. So here, that's where the 0 acceleration comes into play, and that should be, meters per second squared. Oops. So let's write this down. We've got x is equal to 1.1 times 0.48. Cool. And solving that, we get x is equal to 0.528 meters. I think that answers part B. Let's go check. Yep, the horizontal distance from the edge of the table to the point where the book strikes the floor. Check. And we've got the height of the table. Check. Right, because this x right here is this x right here. And this y naught right here is this right here. Okay? So now we're going to move on to the short equation in the x direction. We've got vx minus initial velocity in the x is equal to acceleration in the x times time, which is equal to 0. And that just tells us that Vx is equal to Vx initial. Boom. There you go. You don't have to take my word for it. And we know that Vx initial is equal to 1.1 meters per second, which is also equal to Vx final. Now, in part C, they want us to find the horizontal and vertical components of the book's velocity and the magnitude. This should say and the magnitude and direction of the velocity, okay? So here is the x component, for part C. Here is the y component for part C. And now what we can do is we can represent these velocities as vectors in their directions, and we can move the vectors around to make it clear to us how we can find the magnitude of the impact velocity. And I'll do that now. So we've got the velocity in the x direction. We said right here that the velocity in the x direction is 1.1 meters per second. And I drew the arrowhead going this way because we know the book is moving to the right, just by the way that I drew it. And then we also know that the y component of the velocity in the y is equal to 4.71 meters per second, right? Because that's over here. There's that 4.71. So I'm representing these velocities as vectors, and then because they're vectors, I can take this vector and move it, put its tail to the head of my x component vector, right? And then what I can do is, because these are a right angle, I can draw this hypotenuse for the velocity components and just call this v final, because this is the magnitude of these two. And we find VF by using Pythagorean theorem. We know that VF is equal to the square root of the Vx squared plus Vy squared, right? That's all Pythagorean theorem is. We're essentially finding the length or the magnitude of this vector using these vectors, which are at a right angle. I guess I should label this Vx just to be clear. Okay, so plugging in for Vx, and don't forget to square it, 1.1, and for Vy of 4.71, don't forget to square it, and then take the square root of everything. We get a V final of 4.84 meters per second. Boom. That is the magnitude of the impact velocity. But then they want us to find the direction. They want us to find the direction at which the book is going to strike the floor. And so you can call your angle either here, or you can call your angle here. I'm going to choose to use this angle and call it theta. And we know that the tangent of theta, is equal to the opposite over adjacent. So is equal to Vy over Vx. So using the inverse tangent, we therefore know that theta is equal to the inverse tangent of Vy over Vx. And plugging in for Vy 4.71 and for Vx 1.1, we get theta is equal to 76.9 degrees. And looking back at our picture here, we see that the theta is defined with respect to the horizontal. And that's going in the clockwise direction. So there's actually two ways that you can represent this, because if you were just to say 76.9 degrees, that could tell the reader it's here, or that it's clockwise. They don't know. And so we can either note that like this, with this notation right here, right? Here's the horizontal, and we're defining it like so, 76.9, where that is theta. Or you can say it's equal to 76.9 degrees clockwise. Either of those are acceptable. And that's our answer for C. So I hope this made sense. This is our first video where we've done kinematics with both the X and the Y components. And we were able to actually find the impact velocity with each of the components by using something as simple as Pythagorean's theorem. And we know that by moving these vectors, because they are vectors, we can move them so we can get a picture that's much clearer. So we can use things like Pythagorean's theorem, which we've known for a while, to solve something like an impact velocity. And then just using the tangent properties, we can find the direction at which it's going to strike. So I hope this video was helpful. If you enjoyed it, give it a thumbs up. Be sure to subscribe to the channel. And I wish you the best of luck in the next semester, quarter, trimester, whatever you're doing. I know I'm going to be going into my next semester, hopefully my final one at community college. So good luck. Thanks for watching.